Okay guys, so here we are, section 7.2, Law of Signs, the ambiguous case. So I want to remind you about what we talked about in class today, all this triangle stuff, geometry review, SAA, ASA, SSA, SAS, SSS, and AAA. So those are the 6 things we talked about in class, and we remembered like what the pictures of them look like. What I want to draw your attention to, and the purpose of this notes, is this case number 2, the AS case, or SSA. So excuse my language here, but this is how you're going to remember it. This is the AS case. In the AS case, we might have more than one triangle. So whenever you're drawing the triangle and trying to use law of signs, if it's one of these 4, it's okay. If it's the AS case, we can still do the triangle and solve for it, but there might be the possibility of more than one triangle, which is kind of weird. The other thing I want to remind you of is this AAA case over here. And so in this case, I just want to remind you that I can draw a triangle that looks like this. Any triangle with 50 degrees there, 60 degrees there, 70 degrees there. Remember, they must add up to 180. So that's not new. That's something we've been talking about all year long and what you learned in geometry, whatever. So 50, 60, and 70 do add up to 180. But imagine like pinching that or zooming it on your iPad or your iPhone. So I can make a different triangle with longer sides that still have 50, 60, and 70. And I can make a huge triangle actually that is way bigger than any of the others, 50, 60, 70. So there's actually an infinite number of triangles possible for AAA. Just want you to keep that in mind, except that you just have to make sure that they sum to 180. Okay, so there's a bazillion actually, an infinite number of triangles that pass the AAA test, because you can zoom and pinch and make it bigger and make it smaller, but the angles still stay the exact same. There's a bunch of different triangles for AAA, and that's not what we're going to talk about this section. I just wanted to point that out. It will come up later in the chapter, but just make sure that all the angles in the triangle are supposed to add up to 180, and if you have a AAA case, there can be an infinite number of triangles in that case, okay? So keep that in mind. Anyways, I want to go back to this AS case because it's fun to say AS case. Go ahead, pause the video, and draw this triangle where I have sketch over there on the right-hand side. Go ahead and draw it. Example 1, go. Here's what your triangle looks like, and what I want you to pay attention to really closely, just like we did in class today when we were doing the notes, is we have this angle, this side, and this side. The angle is not included between the 2 sides that we're given. So this, my friends, is an AS triangle. It's an AS case, so there might be more than one triangle, so you just need to be aware of that. Right now I'm going to set up law of signs, so I have this angle and the opposite side, so I can use this as one of my proportion combos, and I have this side, so what I'm going to try and do is solve for angle A. So I'm going to set up law of signs using sine of A over this equals sine of B over this. Okay, so what that's going to look like is 8.94 over sine of 55 degrees, 40 minutes. Yeah, you'll have to type it in like that in your calculator. Equals, remember what side A was? It was 25.1 over sine A. Pause the video and actually show the cross multiplication if you want to. If you're okay with that, you get all the way down to sine of A equals 2.32. So remember how to solve for this. To get the A by itself, we do sine inverse 2.32, and your calculator gives you an error. Okay, well, one thing that you should have noticed, hopefully before you typed this into the calculator, if you tried, was that, remember how the sign has to be in between -1 and +1? Well, this is too big, and that's why we get an error. And in this case, the AS case, my friends, there is no possible triangle with these dimensions. Okay, that will happen in the AS case. This is like the first example for doing this AS type of triangle. Sometimes you have more than one triangle. That's our next example. Sometimes your calculator gives you an error and there isn't a possible triangle. What I want to bring your attention to now is if you flip the page, this is the actual image for example number 1. In this case, remember we were given angle B, we were given side A, and we were given side B. Well, this side B at 8.94 happens to be too small. It does not fit together to form a triangle. Therefore, we do not have a triangle for those dimensions. This angle, this side, and this side. It doesn't fit. Okay, so but how do we tell that without actually looking at a picture? We try law of sines, and what we get when we do that is an error in our calculator, which means there isn't a possible triangle with these dimensions. Let's look at problem number 2. Again, go ahead and pause the video and sketch it, and then I'll come back. Here's our triangle again, you guys. I want to draw your attention. Here's the angle, here's a side, here's another side. This, again, my friends, is another ass triangle. Okay, that means that we might have more than one triangle, or our calculator could give us an error and maybe these pieces actually don't fit together. So let's see. I'm going to set up law of sines. I'm going to use this angle with this side, and I'm going to put sine of B over this side. So here's what my proportion looks like with A over sine of A and B over sine of B. So what I need to do is cross multiply that, and I'm going to end up with sine B equals 0.8979. A lot of you guys have been asking questions about what do we round to. Use a bunch of decimal places until the very end when you round to like 1 or 2. As long as I can follow your work, I'm not super picky on how many decimal places you use, except if you round too much too early. We don't want to round this to like 0.9. That would, because we're not finished with the problem yet. So let's keep a bunch of decimal places until we're finished. So remember how I get this in the calculator is I do B equals sine inverse of 0.8979. And I can do this decimal because it's less than 1. Remember that's the restrictions for sine inverse. And that gives me that angle B equals 63.88. Okay, so I didn't get an error like I did in the first problem, so that means that there is at least one triangle here. But remember, since this is the ass case, here's what you do in order to see if there's more than one triangle. Is there more than one? Here's how you check. Take the supplement of this angle that you just found. Remember what supplement means? 180 minus whatever that angle is that we just found. And that gives us 116.12. So the question you have to ask yourself to determine is if this is the only answer or if both of these are answers, is what you have to do is take that angle and see if it fits with this angle. Can I make, and what I mean by fits is what do those two angles add up to together? Is it bigger than 180 degrees? I mean, you can just do that in your head. 116 plus 55 is not bigger than 180. So that actually works. What that means is I'm going to make this my B1 and I'm going to make this my B2. That means there's two different options of B's, angle B. Okay, and so again, I can figure out what angle C is. I'm going to have two of them because I have two different angles of B. So what I'm going to do is, remember how all angles in a triangle have to add up to 180? So take your calculator and use this angle and subtract from 180. And that gives you a first angle of 60.82. Okay, so this is my first angle given in the problem. That doesn't change. That was given information, but that works with this angle that I found using law of sines and this angle that I found subtracting from 180. Or if I use angle A with this B that I found trying that ambiguous case multiple triangle situation, that means I get a second angle for angle C of 8.58 degrees. So this is where it gets like a little complicated. You need to keep really organized work, and I definitely recommend labeling B1 and B2. Remember, you just subtract from 180 to find that, and then use this angle and this angle to find this one, subtracting from 180. That gives us our first option for C. And angle A with this B gives us a different angle for angle C2. Okay, so just remember what solving a triangle means. We need all three angles and all three sides. So right now, A, B, and C angles are good, and I have side A and side B, but I need to find side C. So I'm going to use side C1 and I'm going to use side C2, and that's going to give me two different side lengths for C. So I know it's getting a little bit confusing, but remember the suggestion I gave you in class was to use given information in your proportion whenever possible, just in case you made a mistake somewhere here with like subtracting. You don't want to use that wrong information to help you find something else. So I'm going to set up law of sines one more time. I'm going to do 22.8 over sine 55.3, but I'm going to use angle C here, and I'm going to solve for side C. So I'm going to put side C1, just because it's going to be my first side for C, and sine 60.82. Cross multiplying there gives you 24.21. This is my option for side C, the first triangle. Now going over to the second triangle, because I know I had two options for C, I'm going to still start off with that same exact proportion that I used, 22.8 over sine 55.3, but I'm going to use a different C here. I'm going to use sine 8.58 over C2. Again, just cross multiply really quickly there to figure out that C2 equals 4.14. So this is like kind of long. I mean, it took me like several minutes to get through that problem, but let me just recap here, and then I'll talk to you about what this picture looks like so it helps make a little bit more sense. But I drew my triangle. It was an ask case, so I know I have to be careful. There might be more than one answer. So I did law of sines, and I found my first angle, and then when you subtract that first angle from 180, find the supplement. If that angle also works with the given angle, then that means you have two triangles. And so my first triangle here, I used sine A, sine B that I found, and I subtracted those two from 180 to get a third angle for C, and then I did law of sines like normal to figure out the side for C. But with this second angle, I had to use the given angle and that one to find a different option for C. Then again, use law of sines with that option of C to find your side for C. Here's what the picture looks like, just to make a little bit more sense. Here's the given information. Both of these triangles have this angle. Both of these triangles have this for side B. And both of these triangles have side A, 22.8. But how do you connect your triangle? Because this triangle connected side A like this, but you could also take that exact same side length and connect it into the triangle right here. And obviously that makes a much shorter third side for C. Okay, so this is the option here, is that when you have two triangles, it's because when you're given the ask case, there sometimes are multiple ways to connect those pieces together to make your triangle. Okay, I just want to try one more example and then I'll save example 4 for class. So go ahead and pause the video and draw this picture, and then I'll quickly buzz through it and we'll do example 4 in class tomorrow. Okay, so I drew the triangle and I set up law of sines here. Again, I want to remind you that this is ASS. This is the ask case. So we might have more than one triangle, or we might have no triangles, or there could just be one triangle. So this is an ask case. This is the whole purpose of this section. So what I did is I did law of sines. So I set up side A over sine of A, and side C over sine of C, and that's this proportion here. Cross multiply, and then remember this number is within the range for sine. It's between -1 and 1, so that's okay. I can inverse it and I get 27.59. Pause the video and check that in your calculator just to make sure you got it. But remember, what I'm supposed to do with that is I'm supposed to see, are there more than one triangle? So I subtracted that number from 180 and I got 152.41. Here's what I want to show you. Does this angle work with this one in a triangle? Just do some mental math. When you add this to this, isn't it bigger than 180? So that isn't going to work. Bigger than 180 degrees. It's too big. So that one doesn't work. There's only one triangle possible. Okay, so this is like the third option. Sometimes there's no triangle, sometimes there's two triangles, sometimes there's only one. This is my only option for angle C. So the only other thing I need to do is do law of sines one more time to find side B, and also find sine or angle B by subtracting from 180. So just remember what solve the triangle means. We need 3 angles and 3 sides. Here's angle A, it was given. Here's angle C, I found it using law of sines. Here's angle B, I subtracted from 180. Here's side C, here's side A. I set up law of signs one more time using the given information to cross multiply to get this for B. Thank you guys for watching. We'll do example 4 in class tomorrow. Bring your questions. Have a good night.